we have a rectangle that looks like this. In fact, a square. I'm sorry, a square that looks like this. And we are being told to find the perimeter of the square, and we have to show it. So I know that the perimeter is going to be 3 plus 3 plus 3 plus 3. So that becomes 12 units. Not too difficult, I suppose. Right? Okay. So then 7 part B says, write down the missing values in table up to row 6. Now I can see visibly in this part that there is an increase of 8 in all cases. So that becomes 36 plus 8, which becomes 44. And 44 plus 8, that becomes essentially 52. Describe in words two patterns in the table for the perimeter of square P. Now, this word describing part, this gets a bit confusing to a few students. How to solve this one? In order to describe words in the form of patterns, first things first, we should always talk about the increase or decrease or the change. So I can say the perimeters of squares are increasing by 8 units each stage. The second pattern that I can talk about is the perimeters are all even numbers. Another example that I can also say is the perimeters are all divisible by both 2 and 4. That's also a valid answer, right? So that's the way how I can prove that this R pattern that we have found is going to be correct. Does that make sense?
Yeah.
Okay. Tell me once you've written it down. And once you're done writing, do tell me, please. Okay? write down a general rule for P in terms of N. Alright. So P is basically the perimeter, right? So we have the sequence being written in the form of 12, 20, 28, 36, so on and so forth. And this is a linear sequence. So we have the formula of A plus N minus 1 multiplied by D, which is the common difference. The value of A is the principal term, which is 12. The value of N remains as it is and the difference is of 8. This becomes 12 plus 8N minus 8. If we take N on one side, this becomes 8N and 12 minus 8 becomes positive 4. So our equation essentially becomes 8N plus 4, the general rule as we call it. Alright. And if we want to verify it, we get separate marks for verification as well. That's the good part about IB, I guess.
Yeah.
Verify your general rule. So how do I verify it? I can verify this by writing 8 multiplied by the values that I'm yet to find. N equals to, let's say, 5, the ones that I had found later on. And I should be getting an answer of 44. So 8 into 5 plus 4, that becomes 40 plus 4, which is 44. 8 into 6 plus 4, that becomes 48 plus 4, which becomes 52. Verification is done for the parts that you had found in your table. Testing is done for the parts that you were already given. So for example, if the question would have asked, test those values. So you could have written, in case of test, you could have written 8 multiplied by 4 plus 4. So that becomes 32 plus 4, which becomes 36. Alright. Let's move forward. Now the fascinating part. Right. I hope you're done with the previous parts.
Yeah.
Okay. Area investigation. Now we can visibly see that a pattern is being followed. Here, let me just make it up to size. Yeah. 9 can also be written as 3 squared. 25 can be written as 5 squared. 49 can be written as 7 squared. 81 can be written as 9 squared. So this is the pattern being followed. Now, automatically, I must know that the next two values should be 11 square and 13 square, right? Eleven squared is 121. 13 square is 169. Predict more values and record these in the table. So we are done with this part already. Out of 20 marks, I think this might be somewhere around 2 to 3 marks. We had to identify the pattern. All right. Describe in words a pattern in the table for area of square A. The pattern is that the area is following a rule of squaring consecutive how do you spell consecutive? Sorry. Odd squared numbers or odd numbers, simple. The area is following the rule of squaring consecutive odd numbers. All right.
Yep.
We're done with this. Write down a general rule for A in terms of N. Hmm. Now, this is an example of um, basically what type? Geometric sequence. So I know that the number should be first things first consisting of n squared. A geometric sequence, again, instead of me teaching it like this, it's given by a multiplied by r raised to the power of n minus 1. A is the principal term, which is 3, multiplied by r, which is the common ratio. That common ratio can be found out by the value of, wait a second, where am I going wrong? General rule for A in terms of n. 9, 25, 49. This is not a geometric sequence either. Hmm, hmm, hmm. Wait. Am I going wrong somewhere, or there is a pattern being followed? Yeah, sorry. Let me repeat it. The equation is going to be given by 2n plus 1 whole square. Why is that so? Look, if I consider the value of n as 1, so that becomes 2 multiplied by 1 plus 1, which is 3 squared, which is going to be 9. And just like that, if I consider the value of n equals to 3, so I get 2 multiplied by basically, wait a second, 2 into 3 plus 1 whole squared. 6 plus 1, which is 7 squared, which is 49. So when n equals to 1, a equals 9. When n equals to 3, a equals 49. So our equation, our general rule is going to be 2n plus 1 whole square. Make sense?
Yep.
Okay. Test your general rule. Now look. You see, whenever we are supposed to be testing, basically, we test on the basis of the values that were given to us in the question. So this is for testing, and this is basically the part for verification. Okay? Do we have enough space down below? No, we don't, unfortunately. So, can I erase all of this? Oops.
Yeah.
I can. Thank you. Okay. Testing. Testing means we solve for the values given. So 2 multiplied by 4 plus 1 whole squared. 2 into 4 is 8. 8 plus 1 is 9. 9 squared equals 81. Tested. Verifying. 2 into 5 plus 1 whole squared. 11 squared. 121. Verify. Justify your general rule for A in relation to the squares. All right. Um, if I was to ask you, this is a square that we have. The area, the length of this side of the square is 3. Find the value of the area. What would the answer be for the area for you? Yes?
Could you repeat that?
If this is the length of the square, what would be the area of the square? It's a very straightforward question. We know that area of a square is given by the formula L squared, right? If the value of L is 3, isn't the area supposed to be positive 9?
Yeah.
Okay. It says justify your general rule, which means the general rule that we had found, 2n plus 1 whole square, how do I justify it? I can say that this length represent a specific length. 2n plus 1 should be equivalent to 3. So in that case, the value of n is supposed to be positive 1, as we calculated in case of perimeters, the previous table that we had here. Not the total perimeter, rather the length. Alright. So now I know that 2n plus 1 can be given as an equation of length of a square.